Welcome. This is Eureka Math, Module 4, Lesson 33. We're going to talk today about moving from solving equations into solving inequalities. And the first thing that I would like to let you know is the goal doesn't change. We're still going to attempt to isolate the variable. The rules that we're going to use to isolate the variable don't change. So if there is addition happening, we're going to undo it with subtraction. If there's subtraction happening, we're going to undo it with addition. If there is multiplication happening, we're going to undo that with division. If there's division happening, we're going to undo that with multiplication. So we're still using opposite operations to isolate the variable. And we have to balance the equation. So nothing changes here except for instead of an equal sign, we're going to see greater than or less than or greater than or equal to or less than or equal to sign. So there's really not a whole lot new to know except for if you're dealing with negative coefficients. And in sixth grade, we are not. So I will show you what happens later on with a negative coefficient, but for now, let me just go through a few examples, and then we'll give you a chance to practice on the exercises, and then you can get to your practice, which is going to be the problem set. So here we go. The first one's an equation, so a little reminder. I have y plus 6 equals 16. I want y to be isolated, so I'm going to undo addition with subtraction. And remember, whatever I do to one side, I have to do to the other side. That's balancing the equation. Positive 6 and a negative 6 is 0, so I get y equals 16 minus 6, and the answer is 10. So there's the first one. That's an equation, just like we've been doing the last week or so. All the rules that we talked about still apply. All right, B. Let's do this one in a different color. How about red? Y plus 6 is greater than 16. Y plus 6 is greater than 16. Well, I still want to get y alone, so I need to get rid of this plus 6. I'm going to do that with a negative 6. Whatever I do to one side, I have to do to the other side. The 6's cancel out. I get y is, well, greater than 16 minus 6, 10. And there's the difference, right? On the first one, we had y is equal to 10. The only thing that makes the equation true is when y is 10. On part B, there are lots of things that make this equation true. In fact, anything greater than 10 will make this equation true. Sorry, inequality true. It's not an equation anymore, it's an inequality. All right, so there's B. Let's see, let's make ourselves some room. I'll get rid of this, and let's work on C. Y plus 6 is greater than or equal to 16. I'm going to isolate y, so I got to get rid of a positive 6 with a negative 6. Whatever I do to one side, I have to do to the other side. The 6's cancel. You get y is, this time, greater than or equal to 16 minus 6, which is 10. So all of the values of y that make this inequality true are 10 and greater. Part D. 3g equals 15. Another equation. So this time 3 and g are multiplying, so I'll undo multiplication with division. Whatever I do to one side, I have to do to the other side. 3 divided by 3 is 1g, and 15 divided by 3 is 5. The only thing that makes that equation true is g equals 5. All right? Let's do a few more. Well, you know what? Yeah, I think you're ready. Why don't you try and pause the video. You try A through F on the exercises. And hold on a second. Is this, this is my last one? It is my last one. It isn't my last one. All right, let me show you these. And then we'll try later. These are still exercises. Okay, m plus 4 equals 12. M plus 4, oops, hold on, 4 equals 12. There we go. I want to isolate the m, so I'm going to subtract 4 from both sides. And we get m equals 8. The only thing that makes it true is when m equals 8. Okay, next one. M plus 4 is less than 12. I want to isolate the m, so I subtract 4 from both sides. And the 4's cancel. You get m is less than 8. All the ways that make this true, this inequality true, is when m is less than 8. Anything less than 8 is going to make it true. All right, let's get rid of all of that. Let's not do that. Let's do it with the old eraser. Okay. C. Let's see what we have. Let me get you another color. I know Maddie's groaning right now. C. F minus 4 equals 2. I want to isolate the f, so I'm going to add 4 to both sides. And the 4's cancel. I get f equals 6. The only thing that makes that equation true is when f is 6. Next one, D. F minus 4 is greater than 2. Nothing changes. Add 4 to both sides. That isolates the f. This time f is greater than 6. So all numbers greater than 6 will make that inequality true. Feeling good about these? You should. We've done these for a while, except they didn't have the inequality sign. But nothing's different. You just solve it the same way. Here's another one. 1/2 h equals 8. I want to isolate the variable h. Normally I would divide by 1/2, but I can't divide by a fraction, so I'm going to, that's right, multiply by a reciprocal. Whatever I do to one side, I have to do to the other side. And the 2's cancel, the 1's cancel. I get h equals 8 times 2, 16. The only thing that makes that equation true is when h equals 16. And finally, f, we have 1/2 h is greater than or equal to 8. And I want to isolate the h, so normally I would divide by 1/2, but I can't divide by a fraction, so I'm going to, that's right, multiply by reciprocal. Whatever I do to one side, I have to do to the other side. Okay? When you cancel out the 2's and the 1's, we get h is greater than or equal to 8 times 2, which is 16. Okay? I told you I would show you what would happen if our inequality was, if our coefficient was negative. So let me just back this up so you can see what would happen if, keep going, if this inequality was a negative. Okay, I'm going to do the same thing. I'm going to get rid of the 1/2 by multiplying by the reciprocal. Only this time, when I multiply the reciprocal, I'm multiplying by the reciprocal of negative 1/2, which is a negative 2 over 1. Whatever I do to one side, I have to do to the other side. And we don't do these yet because you don't know how to multiply by negatives. But this is what happens. The 2's cancel, the 1's cancel, you get h. 8 times negative 2 is a negative 16. But one other thing changes. When you divide by a negative or you multiply by a negative reciprocal, the inequality sign flips. So now it becomes h is less than or equal to 16. You don't need to know that yet, but it's coming. So just keep that in mind. All right, why don't you try? Pause the video, try these next few, and then start the video back up, and I'll show you how to solve them. All right, here we are. Let's take a look. Listen, I know some of you are going, I don't even need these equations. Mr. Shankel, I can do these in my head. I know. Training wheels. You have to show me the algebra. So here we go. M plus 5 equals 6. I want to get M all alone, so I subtract 5 from both sides, and I get M equals 1. The only thing that makes that equation true is when M is 1. Okay, number 2. M plus 5 is less than or equal to 6. Nothing changes. I want M all by itself, so I'm going to subtract 5 from both sides. 5's cancel. I get M is less than or equal to 1. This time, any number less than or equal to 1 makes it true. All right. Erase. And 3. 5h equals 40. Okay, I want h all by itself. I'm going to undo multiplication with division. Whatever I do one side, I have to do the other side. 5's cancel. I get h equals 40 divided by 5 is 8. Only thing that makes that equation true is when h equals 8. Next one, number 4. 5h is greater than 40. Nothing changes. Divide by 5. Whatever I do to one side, I have to do the other side. 5's cancel. H is greater than 8 this time. Any number bigger than 8 makes it true. Like riding a bike, right? I mean, nothing changes. We're just still isolating the variable. We're still using opposite operations to make that happen, and we're balancing the equation. Here's the ones I warned you about a while ago. 1/2 y equals 5. Normally I would divide by 1/2, but I can't divide by a fraction. It's not mathematically possible, so I need to multiply by reciprocal. Whatever I do to one side, I have to do to the other side. The 2's cancel, the 1's cancel. I get y equals 5 times 2 is 10. The only time that that equation is true is when y equals 10. Okay, number 6, 1/2 y is less than or equal to 5. Normally I would divide by 1/2, but I can't divide by a fraction, so I'm going to multiply by reciprocal, yes. So I'm going to multiply both sides by 2 over 1. The 2's cancel, the 1's cancel. I get y is less than or equal to 10. I didn't multiply by a negative reciprocal. I didn't divide by a negative, so I don't have to flip the sign. It stays the way it is. All right, I'll show you this last one. I know I didn't fit them all on here, but well, do you really need to see k minus 3 equals 20? Yeah, I didn't think so. You got it, right? All right. Make sure you show your algebra. Make sure you show the cancellation of operations with opposite operations. Isolate the variable. And nothing changes when it's an inequality. Okay, hope that helped. Catch you next time.